So good afternoon, ladies and gentlemen. My name is Helene Staader. I'm product owner in Data Intelligence product. First, let's go through our agenda. I would like to start with the introduction of SAP DI. It would be a very basic introduction. I would like, in this lecture, I would like to focus on the ML part of our project, of our product. So to look at the product from the perspective of data scientists or data science related roles. So I will go through the typical ML project workflow and then have a look how data intelligence could help you do this workflow more seamless and smooth. Afterwards, and this is the technical part of this session, we have a demo, we have a real customer use case. And for that part, I'm very happy and honored to have those two guys with me. So we have Frank Schmalle from Evonik, who will present the use case itself, and then Frank Kienle from Camelot, our partner, who has implemented this use case and will go into the technical details of it. So then, let's start. First of all, the slide you've probably seen in every session here, but I think this is the key message of the whole TechEd, and this is about the intelligent enterprise. I want Miss to emphasize this message again and show you where you can find our product in this picture. To help you, our customers, thrive in the experience economy, we want to provide the business technology platform capabilities you need to adapt for the business processes in order to turn your data into the business value. And I'm very proud to be part of bringing this vision to life mission, and by developing one of the intelligent technologies called SAP Data Intelligence. So, but before introducing SAP DI, I would like to capture the problems and challenges we would like to address with this platform. So why do we do it? We started with the ML applications development several years ago. And we faced a bunch of problems that we already seen also at the customer side. So they struggling with pretty much the same issues. First of all, it's all about the data. So we have the challenge to manage the data. The most of data science projects fail because of lack of data or bad data. And the most data science projects, to get great results, you have to combine unstructured and structured data. So you have several types of data, mostly not in the same data source, and don't having the same data model. So how to bring them together? That's the first challenge. Then any data specialist will tell all managers the same cliché saying: garbage in, garbage out. That means if you train the model on bad data, the results will be bad. So how to I'm sorry. Yeah, the results will be bad. So that's the problems we have in the area of data. Then imagine you have the data, you have the data set, you start to develop a model. You have to manage a lot of development artifacts. You have the experiments, you have then the productive pipelines, you have a huge amount of trained models and metrics associated with those models. So how to manage to version all of them and manage the dependency between them. That's the next pain point. And finally, you have the perfect model. You would like to deploy it. So you need you need an environment. You need a stable, scalable environment for deployment, for running it in the productive way. So that's, and yeah, exactly, that's not enough. So you have imagine you have the environment, you deployed it, and then after a certain period of time, the performance of the model may decrease again. So you have to redeploy it, you have to retrain, to redeploy it, and without disrupting your application, which is relying on this model, which is using this model. So all these lifecycle topics are very challenging. So I mentioned all these problems. It was obvious that we have to solve this problem for us at SAP, end-to-end, and for our customers, of course. The idea of unified data intelligence platform was born. And the good thing was that we already had a lot of puzzle pieces at SAP already. So let me start with Data Hub. SAP Data Hub is an all-in-one data orchestration solution that discovers, refines, enriches, governs any kind, any type, any variety, any volume of data across your entire distributed landscape. It supports your intelligent enterprise by rapidly delivering trustworthy data to the right users with the right context at the right time. So it sounds like a solution for our first problem, isn't it? So the next, and then we have a lot of machine learning capabilities already there. We have SAP Predictive Analytics. We have SAP HANA ML for running ML algorithms natively in HANA. We have SAP Leonardo ML Foundation, which is focusing on deep learning, on neural networks, providing also support for GPU support for better performance. And of course, if we would like to attract data science community, we cannot miss open source libraries and tools in this picture. So the tools like, the libraries like R, Python, scikit-learn, TensorFlow, Jupyter Notebook for the experimentations. So all these, those are ingredients of our new platform. But what is missing here on this list, and this is what is additional value we would like to bring for the developers who develop the intelligent applications, is the whole part of the life cycle. So life cycle over the development artifacts, data sets, experiments, models, all those artifacts have to be managed and versioned. And this is what we developed on top of it, or currently developing on top of Data Hub. So in summary, again, our goal is to provide one integrated offering with one data science front end and support the full lifecycle management. And of course, at SAP, our USP is always it should be integrated with SAP products. So now, let's quickly go through the typical workflow of a data science project. Again, we have, first of all, we need data. The data often from multiple sources. So we need one central place to access all the data. After you have your data, the data science starts the exploration of the data. Data exploration is typically conducted using a combination of manual and automated steps. Automated activities can include data profiling, data visualization, tabular reports to give the analyst the initial view into the data and an understanding over the key characteristics. So if this initial understanding is there, data wrangling may follow. Data wrangling is the process of cleaning, structuring, enriching raw data in a desired format. So after all the steps, the data is clean and prepared, you maybe would like to store it in the storage, reliable storage, where can guarantee the reproducibility of the experiment or model training. So after the data preparation, we start with the model deployment. The data scientist will start with the model deployment. There is again a data preprocessing step, maybe to bring some fields into a specific format for the specific algorithm. Afterwards, the model training, deciding for a specific approach, and then model evaluation, looking into the metrics, comparing several models, and this is an iterative process, starting again with the next approach. Afterwards, the model is trained. The data scientist would like to bring it into the productive environment to deploy it. Deploy means just bring the model into the environment where it can run. It could be online deployment. That means you get a REST API back and can call this API in your end application. Or you could have also an offline inference where you just run as a batch process and can also use it for the further analysis. So, and the answer for all those steps, there are a lot of tools already there, tools and libraries. But how to build an entire workflow out of it? How to do it seamless and smooth? The SAP Data Intelligence is the answer from our side. So now, let's quickly go through the tools we already have. So, and Frank will show us afterwards a couple of them. But quickly to have overview, let's go through them. So we have for the first problem regarding the data, how to bring the data together, we have the connection management, for example. Connection management tool give you the access to different data sources like SAP systems, non-SAP, S3, Azure, all kind of data sources. So the next, for the exploration, for the data exploration, we have the metadata explorer, which can enrich your data with metadata information. You can do profiling, indexing, and so on. For the wrangling, for the cleaning step and enriching the data, you can use Modular. You can build your pipelines and transform your data. And for the whole ML workflow after the data preparation, we have one tool, one entry point for all operations, and this is our ML scenario manager, where you can manage the ML scenarios. The ML scenario is like a project, ML project, consisting of several artifacts like experiments. We have pipelines, we have models, we have data sets, we have metrics, and all of them you can version at once. You can create a version of all those artifacts. Yeah, and afterwards, you can, of course, use our SAP Analytics Cloud for further analytics. So, with that, I would like to take over to Frank.
Yeah. Thank you, Helene. Yeah, now I think everybody can hear me as well. So good afternoon from my side as well. My name is Frank Schmalle. I'm heading the department Enterprise Data Management at Evonik Global IT. And I would like to introduce into the use case we have implemented together with SAP and Camelot today. But before we come to this, I would like to say some words about Evonik itself, who we are and what are we doing. So here you can see a picture. The one who asked, it is Amsterdam, not Barcelona. I'm sorry. It is Amsterdam, but it could be any city. Well, now you should ask the question yourself: what has a city like Amsterdam to do with Evonik? And at the first glance, nothing. But if you look under the surface, you find many things where our products play an important role in cities, for example. Like in bridges that last long and do not crumble. Buildings that repel dirt. Solar cells that make more out of the sunlight. Refrigerators saving energy, and, for example, road marks, which you can even see in the darkness or in poor visibility. In addition, our products also support the mega trend like urbanization. So our products help to turn roofs into gardens. They support windmills that generate residential local power, or even supports turbines that can use minimal flow for generating electricity. And of course, our products also supporting public transportations, which just enable the urban mobility. So I think it is clear that Evonik is within the B2B market, and we are a chemical company. So we are not selling car tires or towels or mattresses or pet food or tablets. Our products help to produce a certain characteristic or certain properties for those products. For example, our products help to make towels fluffier or helping tires to save energy. Evonik is one of the leading companies within the specialty chemical area. And I brought some figures today with me from last year, 2018, which was, by the way, a very successful year for us. We generated 15 billion euros revenue in 2018 with slightly above 36,000 employees and achieved EBITDA of 2.6 billion euros. Evonik has a global footprint. We are active in over 100 countries. Our claim, our aspiration for the company is building a best-in-class specialty chemicals company. And this also means for us, from Evonik IT, that we also contribute by providing best-in-class IT services and best-in-class data. So this was just a short overview about Evonik. Let's come to the use case. But before we come to the details, I just want to share some insights regarding data management at Evonik. Basically, it started to be a company-wide initiative in 2010 when Evonik started a program to harmonize all our SAP ERP products, SAP ERP systems. And we thought it is a good idea to also start a master data initiative to help to harmonize master data, eliminate duplicates, and even go for a better process in this area. So the program itself ended successfully as planned 2018, and we needed to make up our mind what are we doing with the achievements we have within the master data area. Should we stay at this level, or even we need to go any further? And I mean, it is clear we need to go any further, and we initiated a program, we call it Next Gen Data Management, and started together with Camelot to come up with a roadmap and put important topics within this area on this roadmap. And one special topic is also to find out and to look into new functionalities, new technologies, like artificial intelligence. And we are looking in this area to find out where can AI help us, even in the master data area. So we started with a 2-day design workshops together with colleagues from the business, found 12 very good use cases, and we picked one use case where we thought, okay, this might make sense to go any further. At this time we were lucky because SAP was looking for co-innovation partners to implement first use cases at their SAP Data Hub or SAP Intelligence. So we started together POC to get this use case, which I will explain in a minute, together. So we thought we put together all our strengths, so the technical strengths from SAP, providing the modern platform where we can implement and utilize the machine learning or artificial intelligence functionalities. We took the experience and domain know-how from Camelot, which helps us. And of course, we from Evonik put in our use case and our business know-how. So what we wanted to achieve with this POC, there are 3 major goals. First of all, we wanted to see the feasibility if really the new technique can help and support us also in the master data environment. The second goal was also to find out how we can integrate the SAP Data Hub in our Evonik system landscape. And the third one is important for us, that we need to come up with a playbook with a roadmap how we can utilize what we have achieved so far within Evonik and even roll out these functionality to other, for example, other data domains. So enough from all this theoretically topic. Before Frank is going to show us the demo and how we implemented the use case, I just wanted to share the problem statement. It is out of the material master data environment, and it is related to packaging materials. As usual, if a new packaging type receives Evonik, we need to reflect this as a master data record in our ERP system. And in general, we receive specification informations about packaging material in form of different documents, which are unstructured information, multiple formats, and so on and so forth. And today, a colleague of the technical packaging department is reading all these papers and try to find the right information for the packaging material, like length, volume, height, weight, whatever, and put this manually into a master data record in the SAP system into the purchase order text. And it's the second step, because purchase order text is not really searchable within the system. He also manually maintains the same information and the classification at the material master. So 2 manual steps in this process, and also some numbers here about what does it mean currently for us. But we thought, let's utilize new technologies to make this process much more efficient and also help our colleagues that they can save time and make less mistakes by creating material master data. And how we have done this and how we have implemented this, I would like to hand over to Frank, and he will explain and show what we have done.
Hello. Hello, everybody. So I'm a data scientist by heart. So I developed machine learning models since 7 years, large scale. And I can say you, the most difficult thing is to bring it to enterprise IT or to operations. It's not to develop these machine learning models on laptop or notebooks. It's really to bring it into enterprise level. And this was a challenge. So the entire scoping here was twofold. Number one, find a generic use case, which means unstructured data to structured base. That was a generic use case, so we tried to design a template on this. And on the other side, how to bring it to enterprise level. And when I heard that the Data Hub is merging with the Leonardo services, I said, oh, thank God, now I can do something. Sorry, before, I mean, only a REST service to call it. I mean, we can do it, but there's a huge design flow behind what you have to do and how to maintain this kind of models. So 3 more slides before we go into them. Number one, be designed to end user, and the end user or UI. So, and sometimes even a good sound. Oh, yeah. Hello? Back?
Sí.
Nee, warte mal kurz. Wird ja aufgenommen von dem aus.
It's really tricky now because I have to go into the system somehow. So I will try to manage it. Is it okay now?
Should I hold it?
Yeah, okay, that will be tricky. So number one, UX. So we designed directly a prototype in a UX manner where you can see here something. At the end, it's everything containerized in the back end, so it's all designed by Docker. So my language is now going a little bit more technical, so sorry if I'm speaking maybe a little bit more in depth, this kind of language. That means what we did in the background, everything is based on Docker containers. So even the UI is built on Docker containers that we can port it really fast to different platforms. So our platform in the background was Azure, and on Azure, we installed Data Hub, and just right now, the intelligence platform which I show now is on AWS. So it established different connections through on-premise and in the cloud. And this front end is also running, for example, I will show it on Azure in a Docker container, only to port something towards the end user really fast. The challenge from machine learning perspective was that this documents are highly unstructured. Normally, you can do a classical so-called optical character recognition whenever you have good forms. That means it works very well for purchasing requisites where you know exactly this is my IBAN number or this is my special name, so you can do it. But here we had technical drawings, we had pictures, we had Word documents, we had mails and text. And now how to come up with a framework that we can do natural language processing there with a highly domain-specific topics in the background. So what we did is a so-called iterative system. It's called a reinforcement system. That means it is an expert in the loop system, what we designed. What is an expert in the loop system? So normally everybody speaks about big data. What happens in many applications is that we have even low statistics data at the end because we need to label all this data. The challenge in machine learning is most of the time that we have a lot of unlabeled data, and the same was here in this process. That means we have a lot of documents, but we don't know the truth, how to extract this kind of information. What we did is we built this UI to help someone to stage new information into the systems, and while he is correcting the information or while he is doing this, this is labeling the information in the background for the next machine learning iteration. The pipelining, which I will show now on the data intelligence itself, is 5 stages, 2 machine learning stages step by step. So step 1 is an OCR technique from Google. So we use Tesseract. So inside the data intelligence, we get a lot of pre-packaged open source material, and we use this. So we used a Google Tesseract as a starting point. This Tesseract pipeline part is then going into a further NLP classification part. I will show it how we designed it, and then going to a retraining. It's so-called conditional random field training, where we even extracted more domain-specific information. So if you have any questions towards this deep dive machine learning, so just contact me at the end. I will now go a little bit more deeper into the developer flow, into the system, that you understand what is a new thing about the data intelligence and why I'm quite really positive in how everything is merging now and really what we can do in the background. And also my developers and my team, we were 4 people developing this system, really confident that this is the right path to go. Okay, let's go into the system, which is now going to be a little bit challenging here with a microphone. I will try it. So what? Good. That's always a shock if you do live demos, so if the system is not running, but it is running. So data intelligence. So this data intelligence is a hosted service by SAP, and this particular service is just right now running on AWS. So what you see is a typical overview page for Fury Launchpad, so you're very familiar with this. And in the background, each of these parts is an individual service. If you click on it, it's ramping up a Docker container in the background in the Kubernetes service. That means whenever you have 4 users there, you ramp up maybe 4 containers, and you ramp these containers down. That means whenever I click one of these buttons, we are really elastic what happens in the background, and this kind of services are ramping up. That means everything what you design inside your machine learning environment should be also in Docker containers. That means everything is organized in the background with Docker containers. That's message number 1. That means I like this technique a lot, so maybe you realize it. So this is the future technology. So really cool stuff. Yeah. Okay, let's go directly into, let's start with Annotation Tool. Let's go to the front end. So this is just a mock-up or a prototype just right now, where we have the possibility for the end user to upload a document. In the background, the entire processing part is triggered. If you press this one, I hope. So everything is triggered in the background. We will go to the back end in a minute. And what you see here is that this document is relabeled with these boxes here. This is Tesseract in the background. In fact, Google gives you then the boxes around each of this information in a PDF. And if you start then the AI module, it's starting to processing the information which is now domain-specific extracted and staged to the right side, where the user at the end can just say, submit changes. And this is then connected to the back end of the ERP system. That means it's just to help the user to extract this information faster. Typically, he's doing copy and paste. And you can imagine how many mistakes are done in this. Yeah? So this is the front end part. So we go now to the back end part. Not more words on the front end part, because where is it? The back end part is here the data intelligence. This is way more interesting. So let's go to the scenario manager. What is a scenario manager? When you design machine learning models, a machine learning model is not only the source code of the machine learning model, it is binded to the data source. It's binded to on which data did I just run it or train it. So typically machine learning is always 2-phase. So we train, we have a so-called training phase on the data and a so-called inference stage or prediction stage. That means once I've learned something, I can take this learned module and place it somewhere, maybe at a REST endpoint, and always consume this REST endpoint. Yeah? This is how your chatbot in the background is also operating. It's trained once and operates always on this pre-trained thing. And whenever you have new information, you retrain it. That means you have to always remember that it's an iterative thing. And for this, to manage this, we need this scenario manager. The scenario manager here is coming with a version control in the background. That's good. So as a developer, I mean, we need Git or something. We need a version control. And this version control is a hyper version control over data sets, models, deployments. That's really important, that it's not only about the source code, it's about what we did, where did we train, on which data set. So let's go into this kind of scenario now. The scenario itself is composed of a data set on so-called notebooks. Notebooks. Who ever developed on IPython notebooks or on Jupyter notebooks? Hands up. Yeah, then you like it. I think it's good. So especially at the beginning, when you start to develop a machine learning model, you need a so-called explorative phase. Explorative phase, you just play around with the data. You start to develop maybe in this IPython notebook to understand what is going on. And this is now integrated here. Because I really hate these fragments running everywhere on the laptop. This is absolutely a no-go in many situations. And maybe you have this in your company as well. So here we have bounded to the system. So everything is in the system. So we have the notebooks in the background, the full pipeline. I will show the full pipeline. And then the models and deployment. I will show it also later. So let's go into the notebooks. The notebooks itself, yeah, Jupyter notebooks. Wonderful. What is here ongoing? We are now on an EC2 instance with a ramped up Jupyter notebook, and we have the possibilities to do different things. Number one, we can even upload their data locally to this EC2 instance. That would mean we develop locally, or we could connect in the back end towards our blob storage or our other storage layers, or even to the ERP systems or to other systems. And then we are in the connectivity management systems. That means what we have done here is that we followed a stringent data science process. A data science process means, okay, let us decompose the overall problem in different sub-problems. We had different developers on different notebooks in the background. So we can see here 1, 2, 3, 4, 5 different notebooks. One was for training, one was for exploring the data, one was for doing the NLP in the back end. So this is exactly how you can decompose it. And these notebooks are running. I hope it's running now. That is critical what I'm doing. Restart live, that's always a problem. So in fact, what you see here, you can even install your own requirements, because at the end, I even installed TensorFlow here in the backend. TensorFlow is a deep learning module. So just right now, I'm running here or imported a deep learning module because we need it here for the training. And then I'm here in the system. I uploaded all the data. It's clear structured. And I have here the possibility to do a kind of explorative statistics. This is classical data science stuff where you just look on the statistics. But wait, we have the Data Explorer. How does it link to the data management and data explorer of the overall data hub? In the background, we connect either against a data lake. This is possible via this IPython notebooks, or we can connect directly through the local data. The local data is depicted here. In fact, we can really connect directly to the data lake in the background. That's cool. I mean, the entire data intelligence is coming with a Vora system, or it was, I think, denoted Vora system. That means when you access this data intelligence, you have the full capabilities of a data lake in the background. Elastic, and you can store and access it. Let's go to the Metadata Explorer at this stage, before we go further in the development flow. The Metadata Explorer is a place where you can have a look, oh, where is my data really located? How is my data, how does it look like? And how could I even align this kind of data sets for other teams, you could say. This Metadata Explorer, just right now, is in the background connected to two systems. In the background, we have connected towards an Azure system. The Azure system is just right now hosted by Camelot. And by the way, also Evonik is hosting an Azure System data lake in the background. So we paired up the development path in the background. So we have a connection to the Azure system, because during the pipeline processing in the background, we do a lot of processing of intermediate files. So when you process something like a machine learning model, you never generate one output, you always generate a lot of different output files. Why? Because you always would like to have an inner sight what happens in your machine learning models. That means what we have done here in the background is we connected the Azure system and we processed all these PDFs which are coming in, so there we had around, I think, 1,000 PDFs. Each intermediate result is stored in this Azure system, and the Metadata Explorer gives us the possibility to have a look in this kind of intermediate results. So let's have a look, for example, on some of these documents. This is a view on an internal document now. You can profile it, and you can more or less expose an intermediate result to also other people. So this is called data catalog. So this function is really nice. When we had processed the first intermediate files at the very beginning, we could expose some of these first files to the next developers. This was really working really fine. That's really the workflow what I would like to have. Stable data, please work with this data. Here I exposed it, you can search it, and now you can work on it. Yeah? So the Metadata Explorer is a great way now to index everything what you are doing, and also for the developers to find all the different assets. Let's go back to the ML Scenario Manager. Where are we? It's a Jupyter Lab. Once we computed different statistics on the data, we had the challenge that the PDFs and the OCR module of Tesseract or of Google was not strong enough. So the OCR module of Google is just giving you all the information of your PDFs or of your unstructured data. But in fact, you need now the domain knowledge of an expert inside your model. How have we done this? We used a so-called conditional random field model in the back end. That means we are using techniques like in speech processing. In fact, we are coding distances between words, but in 2 dimensions. So even speech processing or your chatbots are operating in a way that the word what I'm saying now is somehow associated to the word which is said a couple seconds before or after it. So that's the reason why this deep learning can identify the relation between these words. What have we done? We did exactly the same techniques on the PDFs, but in 2 dimensions. That means we implemented a special deep learning framework where we could say, okay, if we have to extract the name height or width in a document, there's a highly probability that it's coming to the right, left, down, or even to the left, because it's technical drawings. It's not like a structured document, but there is a kind of structure behind. It's not that you have this keyword here and then another value there. And normally we have to search for so-called triple pairs. Keyword, value, and the unit. That's a special thing here. So we have to search for the triple pairs in the documents. Yeah, you cannot just search for the word like you would typically do it. You have to learn it. And this is exactly done at this stage. So once we have set up our model, we have to build a full pipeline. Now let's go to the so-called modular. What is a modular? The modular in Data Intelligence or Data Hub is always operating on individual operations and is building more or less a full graph. That means what you see here is a full prediction pipeline. It looks simple at the end because it's composed of some modules where a lot of genie magic is happening in the background, but with a clear sequence of steps. It's like functional programming. So you should always operate your operators in a way that they are nicely encapsulated in an operator. Many operators together build a so-called graph. And this is exactly what happens here, which is a prediction pipeline at the end. Remember at the beginning, I had this PowerPoint file where we had the OCR module from Google, then our own machine learning module, and this is exactly the OCR here in the middle. That's more or less an enriched file from Google Technic, open source. I mean, this was a promise of the Data Hub and the Data Intelligence, that we can now include all these open source fragments. This was partially binded already from the SAP libraries, which are coming feature-rich here on the left side. If you go on these operators, you get a lot of different operators already designed by SAP that we don't have to reinvent the wheel. As a designer, it's really nice, because once we design such an operator, we expose it to the other developers. It's like a again, version control system. Yeah? If you go inside this kind of operators, I will only do it for this one. In the background, there is a so-called Docker repository. So each of this operator comes with their own container. Own container is designed via a Dockerfile. Let's go into one Dockerfile that you can see it, how this thing looks like. This is the inner core life of a Dockerfile in the backend. So you see this Dockerfile is running, in this case, on Ubuntu 18.04. We have to change that anyhow to SUSE. Maybe you know it, that SUSE will be the future base class in the background of this kind of technique. So we have to pull in a SUSE environment. And then you install all these fancy things, Tesseract, OCR, pip install NumPy, PyStruct, Pandas, scikit-learn, all the nice packages we know from data science environments is now bounded to this kind of box, which you have seen in the operators. And even you can even bring in policies. So for this design, we had to increase the inner memory usage consumption. So you can go into the Docker container and say, OK, let's have 4 gigabytes space for this kind of Docker container because it's larger. So that's really in-depth design. That means you need DevOps know-how to do this kind of Docker things. But once you design this, and that's a good thing, I never had to touch this Docker container again. This is our Docker container now for all kind of NLP tasks, what we are just right now doing. That means you have to do it once. Now you have a Docker container. Now you can do a lot of different things on top in the background. Yeah, is it clear? So it's really a modular system, how you can really hand over knowledge, how you archive knowledge, and how to bring it also in the enterprise to an enterprise level. Because I really, sorry to say this, but I hate it when I see developers to install locally kind of packages and everything, and then think, OK, hey, we just have to ship it to the enterprise world. This is just not working. Yeah, so this is exactly what we solve here in this environment. So let's go back to this entire pipeline. Once we upload, you've seen it, when I upload something into the Azure, this read file is triggered. We go to the first stage, then we go to the second stage, and finally we write the final result. And our front end is more or less just pulling this written file as a visualization layer on top. And we just did it in this way, because of course we could stage it directly in any kind of system. So we have in the other projects where we go directly to the BW, to the business warehouse. Yeah, so where we just clean up some data and then stage it directly in the business warehouse. Yeah, and this is exactly the connectivity management what we mentioned at the beginning. We can connect against all of these different assets. So I have, I think, 3 more minutes. So one thing more maybe in the scenario manager, and then we are open for questions, or we have a wrap-up slide still. Yep. So let's go to the full story of API deployment. So what you can do in this new scenario manager is that you can bring in the data assets where you train your model. You can build your full training pipeline inside your scenario manager. Once you trained your entire pipeline, you will get an endpoint for your trained model. And this trained model can be put into a REST API. And this entire step, which is shown here with 2-3 clicks, you can do normally. Normally, you need a long time to do it. Here, this small model, this is our toy example for training on data intelligence. We deliver also trainings on this, but we did this in a couple hours. And that's normally not possible with other technologies. Yeah? And this is really, really the great benefit what we see just right now. So this endpoint is just right now active. We can even access it again through this notebook, but the time is running up, so I will not open it. But the endpoint is now active. It's a fully trained machine learning endpoint inference stage. And whenever you do this, you can expose your service to every other application, wherever you want to call your API at the end. Yeah. In summary, so that's my last statement, I like it. I mean, I really screwed up some designs also in my past. And I think I learned a lot that this kind of deployment is really, really tricky. It's really to run a stable machine learning model in an enterprise environment is the biggest challenge of every machine learning designer. It's not the machine learning model itself. So this is the first time that I have now the possibilities to expose really rapidly in a kind of life cycle management way the machine learning part. So this is a very quick deep dive technical walkthrough. I hope it was not too technical. When you have any kind of questions, please ask me. And I think we are in the summary.
Yeah. Sure. Yeah, maybe just, perfect. Yeah, summary from my side. Thanks, Frank. And yeah, many things need to come together to make this happen. It's always great to see that at the end it works. Basically, you may remember the 3 major goals we had at the beginning when we started the POC. For example, show the feasibility using AI technique, and we showed it. It is really useful also in the master data environment. Second was how we can deploy this in an enterprise system landscape like Evonik. And yeah, we have also shown this with Azure together and Microsoft and SAP. So this is also working in our environment. The third goal was having the playbook for rollout, the next steps. Honestly, we are working on this. Yeah, this is maybe a short wrap-up from my side. So it's even helping our colleagues in this area. And you might remember the 8,000 materials, packaging materials. Of course, this is not really a business case you can make with 8,000 material masters to create those more automatically with higher quality. But I leave you with a number. We have 1 million technical materials where you can apply most of the functionalities we have seen here as well. So I think now we are open for questions.
No questions.
Not all at once.
Just a second, there is a micro. So the session is recorded, so.
You mentioned that there were design thinking before you start the POC, and maybe you could share what other ideas you discussed and how you choose this case and what return of investment you expect from this.
Yeah, thank you. Good question. We had multiple ideas in this area. I talked about 12. I don't want to show all of them. But I think more important is the question why we choose this one. And honestly, the major argument for this one was because we had business buy-in and business support. This is more important to have somebody with the knowledge which jumps on the train helping you, especially in this stage. It makes no sense to have a theoretical model you show to somebody who is not understanding this. And this was our driver. We choose this one, even if I just explained it's a small area with less material numbers, but this was mainly the main driver. Business support, just simple. Return on investment, yeah, we will see in the future. And as I said, if you scale it up with 1 million of technical materials where you can reuse those things and those functionality, then it really starts to, as always, making money with it. For this particular part, you can say we save at least 20, 30 minutes already just for the packaging material environment.
So very, very interesting use case. As I said, the question, how long did it take you from effort perspective to go from acceptable prototype into something that is accurate enough to give to the hands of the end user without adding work but removing work. What was the effort ratio between that and something that was good enough?
I think it's a quite difficult question because it was an iterative process. So it's not that we split it in this hard ways. Okay, do first this and then trying to get benefit. So the overall use case was around 3 months.
3 months, yes.
3 months. Until now to this level, but you've heard that there are some developers in the background, and in parallel I was with the IT of Evonik continuously in exchange because this enterprise scale-up was the highest priority of the IT, and in parallel they implemented 5 more use cases in the meanwhile, so it's really difficult to say, and just right now it's more or less the question how to operationalize now. It's larger, and that's more questions than to you, what is the next step. So 3 months to get to this stage.
Thank you very much.
Thanks. There is a question.
Okay.
Once you've trained the model, is it considered static? So if you use it in day-to-day business, does it continue to be trained, or is it static as you deployed it in the RESTful service?
So normally you train it once and it's deployed in the service, and you have to trigger a retraining. So the advice typically that you retrain, it depends on the application, maybe once a week, or depending how many relabels we get into it. So here the model shows a good performance after 50 documents. So then we see that the AI model is getting really traction, and we expect that you need around 30 more documents or 40 more documents that retraining makes sense. So depending how often you would do it. But static, and you doing the retraining then occasionally, maybe once a week, once a month, depends of the use case then. Yeah.
Thank you very much.
Thanks so much.